Hello and welcome to another video to learn AWS. Here I'm going to explain something from scratch, like from zero. It's very good for anyone who is new in building infrastructure in AWS. Here we practice on building a new VPC, attaching internet gateway, configuring route table, and then know how to make a subnet public and how to keep them private. And then we look at security groups, and we like to test the connectivity by using ICMP protocol. I mean by ping tool, right? We test connectivity. Now, this is a very simple topology here. We have three subnets in our VPC in maybe one availability zone. For us, no preference right now. And then we are looking to create a VPC, and actually the VPC IP block is 10.10 here, right? Then we have 10.10.00/16 in it's our IP block, original IP block for the VPC, and then we slice it out to many different subnets. .1.0, .2.0, .3.0/24, and then we launch our instances there. My suggestion for you, if you follow me, is to take one screenshot from this page, right? And then look at this screenshot while you are doing your practice. I do something same, right? I follow exactly whatever we have here, and then I put some steps for you to make it like more clear what I'm doing, but I will explain all different steps there. Let's start. All right. So the idea here is first create our VPC. If you're in your management console, then let's start by looking at VPC here. And then let's go to VPC. The good point is although even if you have a VPC with same IP block, you can go and you can create one again, right? But right now I do not have that same, so it's good to go with my VPC here. For IP block, I have 10.10.0.0/16, right? The rest of that can be just the default. Now, the next step always is to create subnets. Let's create subnets for our VPC. This is my VPC, and then the name of my subnet is subnet 1, the first one. For availability zone, no preference, and then the IP block for that subnet. It's good to always put some meaningful names, right? 1.0 is my first subnet. Done. Then let's create the second one in my VPC, and then this is subnet 2, and then 10.10.2.0/24, right? And then the third one, which is again my VPC, and let's go to subnet 3, and then 10.10.3.0/24. Great. Now if you look at subnets, you should see the new subnets for the new VPC, right? Good. Now let's go to internet gateway first. We know that for any VPC we need one internet gateway to connect to internet, right? If we need any connectivity to public network, otherwise we don't need it maybe. So let's create our internet gateway. Let's say my VPC internet gateway. Just create, and that's it. Done. Then if you go to action, you're able to attach it to a VPC, and you should do it for all internet gateways. So let's attach, and if you go to the list, then it shows the only VPCs without internet gateway. So this is the only one that doesn't have internet gateway on the list, so I can attach my internet gateway. So internet gateway creation is done, attached to a VPC, we are good to go. Now the next part is very important. Why? Because let me bring the topology here. Why? Because we are going to make instance 1 and instance 2 public subnets, and we like to keep instance 3 private. Why? Because we like to connect to instances in these two subnets by SSH from public network, and then test connectivity to the third one. Now let's see how can I make these two public by using route tables. Now to do that, let's go to route tables and let's see what's going on here. By default, always there is one main route table for some of these VPCs, right? Actually, it's not here. It wasn't there. Don't be scared. We need to just refresh the page. So for my VPC, there is one default route table, right? Then if you go to the route table, then you can see there's only a route for internal traffic, nothing else, correct? Now, main route table has some features, and then for route table you can also create non-main route tables. You can say this is my VPC, and I like to say this is my non-main. I'm telling you what's the difference. This is on my VPC and done. Now, in any route table, we have one tab which is subnet association. Now, if you define any route, then if you associate subnets to that route, then those subnets will be affected by the route. Let's see how it works. I'll show you. Now, my point is I like to make those instance 1 and instance 2 public. So the first step to make them public is to define a route going to internet. So this is my new route table, right? And in my new route table, I will add a route for internet gateway. If you do it in your any of these main route table, the point is in any of these main route tables, because by default all subnets are associated to the routes, then you cannot keep subnet 3 a private one, right? Because then if you add a route for internet gateway here, by default all 3 subnets will be there, right? Will be associated and they will be affected. But I like to assign and associate only in subnet 1 and subnet 2 to a route with internet gateway to make them public. So let's go to non-main route table. Let's add a route to go to internet. So I said if destination is everywhere internet, let's use internet gateway and the only internet gateway in my VPC, and done. Now this route knows how to navigate traffic to internet and which subnets should be affected to make them public. Let's edit and let's associate subnet 1 and subnet 2. Now I have a route, it's not main, it has internet gateway, I have 2 subnets are associated to that one, and by this, in this step, we could make subnet 1 and subnet 2 public subnet. Means traffic from these 2 subnets has a route to internet, right? And because I didn't add or associate subnet 3 to this route, their subnet 3 will be kept as a private subnet, no access to internet, right? Okay. So we could create our main VPC, new VPC. We created the subnets. Route table is there, and then these 2 public subnets. One keeps private. Internet gateway is there, and we are good to go with the next item, which is EC2, and launch our instances. Right? So let's do it. Something to remember is for instance 1 and instance 2, because finally I asked to connect to these two by SSH, right? Or maybe only instance 1 here, but I like to practice on both of them. Let's see. Because I need to connect to both instances by SSH, then we need a key. We need to assign a key and also assign public IP address to instance 1 and 2, because later I will connect to these two by a key. So to give you a better idea, I will do something correct on instance 1 and I will do something incorrect on instance 2. Then I like to show you what can be the issue. So let's see. Launch instances. This is my instance 1. Let's go to Amazon Linux machine. We leave the machine image as it is. We leave 64-bit. For instance type, it's feature eligible, very small one, micro, t3.micro, leave it as it is. It's instance 1, so I need to have SSH connection and we need a keeper. I use a keeper that is already created here, right? So I use this vault key, I have the key file and everything is good for us to use this one. You can create your own key, but please remember you need to download and keep the key file. So where is the instance? Instance is in my VPC. I like to put it in subnet 1 and it needs public IP address. So auto assign public IP is enabled, and for the security group you can leave it as it is. Later we can change it, we can modify it, but for me it's good because I need only SSH connection to this machine, and SSH is there by default enabled from anywhere. So this security group is good for me by default. SSH is there. I need only SSH port open, port 22 open for this instance, so I'm good. Although it's not secure, but I'm fine, it's a test, right? For the rest of that I'm good. Just go to launch. Now second one. For the second instance, I told you I like to make some mistakes to show you how it works. This is instance 2, right? Instance 2, again, I like to have Linux machine, everything same. Let's put a key, right? But I like to put it in a private subnet just to show you how it works. So let's go to my VPC and then let's go to subnet 3, which is a private one, and then let's even enable public IP version 4. Let's enable the key. I like to show you how a private subnet doesn't have access to internet. And then I need to have SSH connection. I know that finally it doesn't work, but let's see. And that's it. Launch. And I need one more instance. And the instance that I need as instance 3, I like to keep this one private. So subnet 3 is a private subnet, and I like to keep this instance 3 also private, secure. So while I will instance 3, while I will create that one with Linux machine again, and then I do not assign any key, so I proceed without a keeper, right? And when I put it in my VPC, I put it in subnet 3 and no public IP address, right? So no key, no public IP address. It's in a private subnet, and I do not need SSH right now. But remember that because instance 3 should accept ICMP packets later, so it should have ICMP protocol or TCP port 22 or ICMP protocol open, right? So instead of SSH, I need, for instance 3, I need ICMP, and go to all ICMP, because if you do custom, then some signalings will not be there. If you like to have all handshaking and all signals for ICMP, go to all ICMP IP version 4. From anywhere, for now it's okay, it's the test. So for instance 3 only, we need ICMP open, and now launch. So let's see. We have created all instances, and then let's refresh it. It seems that still instance 1 is pending, and then instance 2 is kind of ready, instance 3 is running, and instance 1 is still pending, and I need to wait for instance 1 to be sure it's running properly. So I make a pause here to be sure that all of them are running properly, then I come back to do the test. Alright, so I have now 3 instances are kind of running. Instance 1 is initializing, which is fine. I can go and do some tests, show you something. Now, we remember that for instance 3, we're supposed to keep it private and secure, so it doesn't have any public IP address. It has only private IP address, right? Which is correct. It's in VPC in subnet 3. So it's verified. Then let's go to running instances. Now I have instance 2 with public IP address, and then it has private IP address. The only thing is that if you go to connect, right, then you remember that I put it in a private subnet, and because I like to connect it by SSH, they said that this instance is not in public subnet, and the reason is that I put it in subnet 3. So you see that how private and publics are different. Even if you do not make it public, you it's private subnet, and you cannot send any traffic to internet, right? So instance 2 doesn't work for sure for us. So we can just forget instance 2 right now. If you like to have another instance, you need to create another one and put it in a public subnet, right? We cannot change the subnet right now here. Okay. So the only thing that works right now, hopefully, is instance 1. All right. So let's go to instance 1. Everything is done, right? Checks are done. So instance 1, and if I go to connect, as you see, no alarm, so it means that hopefully I can easily connect to instance 1. So fingers are crossed, right? Let's see. This is SSH to instance 1, and it's done. Good. So here you can see the IP address 10.10.1.57. This is the private IP address of instance 1, and I'm going to grab IP address for instance 3, private IP address for instance 3, to do the ping, right? Now I can say let's ping, and then the private IP address of instance 3, and it works, right? Okay, if you leave it, it runs forever. Now let's Control C, stop it. Now let's see some items. For instance 3, let's look at its security group, like firewall rules. In its firewall rules, the only thing that we need is ICMP packets should be allowed. It's from anywhere, which is fine. For us, this is a test. But if you like to make it very limited to only instance 1, there is a way, right? What's the way? This is instance 3. Let's go to edit. Right now it receives ping from all everywhere. I don't want it, right? I want to make it very secure. So let's go to EC2 instances. Let's go to instance 1, and this time I like to grab instance 1 private IP address, right? Why? Because then instead of all zeros, I can say, let's remove it. I can say, hey instance 3, you can accept ICMP packets from only instance 1. /32 means only one IP address, and save. So let's see. If I go to instance 1 again, and if I ping instance 3, it should work again, right? Because now instance 1 has access to or that port is open for instance 1 and not others, right? If you like, you can test it on other instances if you have any, to see if it works or not, but for sure it shouldn't work on any other instances. Okay, so instance 1, just to like check, instance 1, let's go to security group, has only SSH enabled from anywhere from internet, which is fine. And instance 1, we do not need any other protocol open in this case. And on instance 3, let's check it again. On instance 3, on security and security group, we have ICMP packets open, and the source is only instance 1, so it's very secure. Only one instance can ping instance 3. Okay, again, let's come back to the route table just to again be sure that you have a complete understanding. In route tables, while there is one main route table by default, I've created another one. Why? Because in the new one, which is a no main route table, I've attached I have a route to internet gateway, and then I only associate the subnets that are going to be public, and I keep the other one disassociated, and this subnet 3 will be private. So by doing that, you can make subnets public and private. Okay, so we are done. I hope you enjoyed this one, and you can follow me to do this practice, and good luck. Maybe see you in another video.